All right, this is the 10.3 video to complete the set of notes for that day, looking at measures of dispersion. Now, dispersion means the spread out or scattered, how far something is scattered from the center of a distribution. So we think of it as spread or dispersed or scattering. There's two different types of dispersion that we measure. Range, which is one of the least interesting. It is just the difference between the largest number in your set and the smallest. So how far out is it between the lowest and the highest? Now that just tells you smallest to highest. So that just tells us that difference. But standard deviation is the one we're going to practice calculating, and this one is what's called, it's the square root of the variance, but you have to know what variance is. It measures essentially, the standard deviation is a way of thinking about the average deviation each data item has from the mean. But because when you go and look at how do I figure out if something is far away from the mean or close to the mean, we subtract and find the difference between the mean and that item. Now, so if you do item minus mean, what you're going to notice is that some of those answers will be positive, some of them will be negative. So you can't really average those together, because what will end up happening is if you have symmetric data, it'll actually just equal 0 every single time. And that doesn't actually accurately depict the dispersion of the data. So we have to square all those little differences, and I'll talk about that in the formula in just a minute, and then add those all together. We divide by n minus 1. There's a big reason behind that not being the full set of data. It's -1. It just helps for correcting kind of what we've been doing. And then because we squared everything at the end, we take the square root. Now, if you don't take the square root, you'll have the variance, which is another measure of dispersion. But typically when we're doing stuff, especially normal distribution, which we are going to cover together on Tuesday, we need that standard deviation. So these are the formulas for the sample standard deviation for just a set of a list of data. And then we have the grouped data formula, which notice it has the frequencies involved. I did notice that there were two typos on here. This was supposed to be X sub I and X sub I for that. So what this says is we're going to take each individual item in our data set and we're going to subtract the mean from it. So we have to have the mean first or we can't find those deviations. Because some of those are positive and some of them are negative, we will square all of them to force them to all be positive. We'll add all of them up for the whole list, and then we divide by 1 less than our sample size. So if our sample had 10 items in it, we'd be dividing by 9. Then to get back to kind of the regular, how far is everything kind of on average from your mean, because we squared everything, we take a square root. So I'm going to show you how to use this first just for a small set of data, and then we'll do a slightly larger one, and then we'll also talk about those grouped data ones, okay? So suppose a random sample of 5 parts is selected from a manufacturing process, and these parts are found to have the following lengths in centimeters: 5.2, 5.3, 5.2, 5.5, and 5.3. Find the mean and the standard deviation of this sample, because like I said, you have to have the mean or you can't find the standard deviation. So when we find the mean, we do it just like we did in 10.1 and 10.2. Since this is just a list of data, we're going to say that X bar equals, we add all the items together. So sorry, my pen's not behaving the best. 5.2 plus 5.3 plus 5.2 plus 5.5 plus 5.3. We had 5 items, so we divide by 5. And that gives me 26.5 over 5, which equals 5.3. Okay, so that's our average. Now, the way that I find the top number of my standard deviation formula. So I use a little table to help me calculate all of this. So the first thing I do is I write all the elements, which are X sub i's. These are the items from the list. So we had a 5.2, a 5.3. You could put them in order from least to greatest if you want. It's not required. 5.2, 5.5, and 5.3. The next line, we're going to take each of those items and we're going to subtract the mean from it. Remember, our mean was 5.3, okay? Because that's what we got up here. So we will work that out. And then we are going to square each of those little deviations, because this is called a deviation from the mean. And we square whatever answer we got in that previous column. Now, On this, I usually do a lot of this on my calculator and just write things down as I go. So 5.2 minus 5.3. So notice that's that first item minus the mean. That's going to be a negative 0.1. If you use the square button on your calculator, that will square that negative as well if you have the little power button. If not, you might need to make sure you put it in parentheses first. But if I square that, I get 0.01. Then we do 5.3 minus 5.3 because that's the item minus the mean. So that one's going to have 0 as its value. And if you square 0, you get 0. Then we have another 5.2. So if you have a repeating element, you don't need to do it all on your calculator again. You just bring that information down. We need to do 5.5. So 5.5 minus the 5.3 is a 0.2. So that's the subtraction step. And then we square that, 0.04. And then 5.3 was a repeated element again. So 0 when we subtract 5.3 minus 5.3 and square it, and you still get 0. So notice, if you had added these together before squaring them, the problem is that would have all canceled out because this ends up being actually mostly symmetric data here. So we can't just add them together and say, oh, now I'm going to divide by how many items I have. That's not the right way to do the average of the deviations. We need to add together this column. So we're going to sum all of those deviations squared, okay? So we add that column. That's going to be 0.02 plus a 0.04. That's going to be 0.06. So in my standard deviation formula, I'm going to write S equals square root. The 0.06 is my numerator. N minus 1 is how many items did I have? I had 5 items minus 1. Oops, excuse me. Allergies are getting me today. So that's going to be a 4. So this guy right here came from 5 minus 1, just in case you're wondering where that came from later. So we're going to type this into our calculator. So when I do it on mine, I have to do the inside part first. I know a lot of you have fancier scientific calculators than a computer calculator. So you will probably be doing square root button first and then typing in your numbers. So it's 0.06 divided by 4. And then this calculator requires me to do that part first and then tell it to take the square root. We usually round these to 2 decimal places. So the standard deviation is 0.12. So that's our S. This is our mean. Now, what does this mean? A standard deviation tells you, on average, how far the data spreads out from your average, your mean. So if you add 0.12 multiple times to this and subtract it from your mean, it gives you kind of a way to gauge how spread out your data is. And usually we never add and subtract it more than 3 times. So we're going to look at that at the end of this section. We're going to look at just a visual example of what we mean by that and why it's significant. This section is purely to focus on practicing the calculation. Okay. So the grade level reading scores from a reading test given to a random sample of 12 students are listed below. Find the mean and standard deviation, round to 2 decimal places. Okay. So I'm going to find the mean first. And again, you can do some of this off on the side if you need to. I'm going to add all those elements together. So 8 plus 8 plus 14 plus 14 plus 12 plus 14 plus, I actually see 3 11, so I'm just going to add a 33. And then I have 9 and 15 and 15. So I added everything. I just kind of tried to make it a little quicker for myself. So that has a total of 142. We had 12 students in our sample. So if we do 142 divided by 12, we're supposed to round this to 2 decimal places according to the directions. So my mean is going to be approximately 11.83. Then I'm going to make my table. Now I might have to do multiple columns for this, just depends on how small I can write. We have each of our items, and we have the item minus the mean. And then we're going to square those. Okay. And I don't need as long of a bar for this. Okay, so let's see. I would probably list these in order from least to greatest on mine, just because there's going to be some repetition. So 8, 8, 9. There's 3 11s, because all of these will have the same answer. So might as well just do it once and easily find the rest. 12, 3 14s, and 2/15. I think I might be able to get it all in one set of the table. Sometimes I'll do a second table if I run out of space. Okay, now remember, we're subtracting 11.83. That's our mean from each of these. So there's the mean we found. When we go to do our item, we'll do item minus 11.83. So 8 minus 11.83 is a negative 3.83. I'm going to write that for both of the 8s. It's true for both of them. Then I square it. Notice it turns into 14.6689. So that's going to be true for both of those. Okay, then I need to do 9. So 9 minus 11.83, because that's my mean. This tells me how far away that item is from the mean, distance-wise. Then we square it, and that's 8.0089. Notice no duplications for number 9. Okay, for 11, we've got 11 minus 11.83. And that's a negative 0.83. Now that's going to show up for 3 elements in my list because they're all 11. So that's the difference. And then we square that. 0.6889. I need to write that 3 times as well. Okay, then we're going to do 12. So 12 minus 11.83. That's 0.17. We'll square that. That is 0.0289. There's only one of those. 14 minus 11.83. Every time you're subtracting the mean. So that's 2.17. I have 314. So I get to rewrite that 2 more times. And then I'm going to square it. 4.7089. And again, that's the same element 3 times. So we write that 3 times. And then we have the 15. So 15 minus 11.83 is 3.17. And then when we square that, we get 10.0489. And that's for both of those. Okay, so remember, this sum right here is going to go in our numerator of our standard deviation fraction. Okay. Now, I did this off camera because it's a lot of decimals to type in. When I added all of those together, I got 73.6668. That's my numerator. That was adding that whole column together. So 73.6668. The number of items was in 12. And remember, we do 12 minus 1 in the bottom, so 11. Okay, so we need to type this in and get the standard deviation. So 73.6668 divided by 11. That's my big long decimal. I'm going to take the square root of that and I get 2.59. Now we have a follow-up set of questions on this problem. It says, what proportion of the scores lie within 1 standard deviation of the mean? So to find that proportion means like a fractional amount. So we have to actually figure out what range this would be. So here's what I was talking about a minute ago. Once you have your standard deviation, you can take your mean, which was 11.83. And if you have 1 standard deviation, you're just adding and subtracting just once the 2.59 from that value. So this is going to give you a range that we would be within 1 standard deviation. So the range of values that fit that would be 11.83 minus 2.59. That'll be the lower boundary. So that's 9.24 to 11.83 plus the 2.59, 14.42. Now that's not our answer. That's just if you take your mean and you add and subtract the standard deviation once, you've gone 1 standard deviation on each side of your mean. That's how we say that. So then you look up here and you say, well, which numbers are going to be in this group? Well, it has to be It can't be 8 or 9 because that it starts at a 9.24. So that's 9 is too low for that. But 11 would work. Let's see. 12 is still in that range, and 14, but not the 15, 9, or 8. So that's 1, 2, 3, 4, 5, 6, 7 out of the 12. So the answer they're looking for is 7 elements out of the 12 were within 1 standard deviation of our mean. So a little more than half. Now, what proportion of scores lie within 2 standard deviations? So what you do to get this is you're going to take and add and subtract the standard deviation, not once, but twice. So to represent that, we kind of double it before we add or subtract. Okay. So, because you're going 2 groups of 2.59 away from the mean. So that's a 5.18. So I'm going to take 11.83 minus 5.18, which was 6.65. And then I'm going to go to, and you could just add another 2.59 to the top of this last round. That also works. But if you use the formula over here, we're saying we take our 11.83 and we said that double the 2.59 was 5.818. So we add that. So that's 17.01. Now, if you notice, now we can throw in a couple more elements. In fact, I think all of them. 6.65 is low enough that 8 and 9 are now included, and 17 is bigger than 15. So now, just by doing this twice, we now have 12 out of the 12 items are included in this range, which means we're at 100% or 1. Now, it's also going to be this answer for this one, because if you've already included all the answers in the range 2, essentially, you add again and subtract again, you're still going to have all of these numbers in your range. But I will at least show you the answer for those. So when you do 3 standard deviations, you triple the 2.59 and then add and subtract it. So when I did that, I got 4.06 for the lower range up to 19.6. And again, all of our numbers are in that range. So 12 out of 12. Okay. All right. So I'm going to leave this one as one to try on your own, but I am going to write the key up before I post it. Mainly just because these are the problems you really have to try on your own to know if you're doing it right. It takes a little trial and error. So please try this one on your own. And it won't be recorded on the video part, but when you get done watching the video and you've tried it, reference the ink notes that I'm posting in that announcement as well, and scroll down and check that you got it correct. Okay. So let's go, because it's the exact same problem type. We're just dealing with 2 decimal places, so we're rounding to 2 decimal places as well. And they still have you do what's the proportion in each part. Okay. All right, so that leads us into what do we do if they give us grouped data? Grouped data is when you have an interval and you know a frequency attached to that. We don't know what the actual list of data is. I just know that 3 of the items in my list fell somewhere between 0.5 and 3.5. So we don't know if it's, a 1, a 2, and a 3. Maybe those were the 3 elements. Maybe it was 3 ones. We don't know. So the way we do this is just like what we were doing with mean and median before. We have to first get the midpoints. Okay. Just to recap, the midpoints are found by adding the 2 interval parts together, and you find the middle of that. So you cut it in half. So this would be 4 divided by 2. So this midpoint is 2. And we learned last time that if you look at the beginning numbers, you can see the class width. They are increasing the intro value by 3 each time. That will also be true for the midpoint. So once you get one of them, you don't have to do this formula over and over again. You just need to look at the class width. How far up are we going each time by value, by adding? And then that's the same for the midpoint. So notice 5 is halfway between these 2 answers. And if we add 3 again, we're going to be at 8. Add 3 again, we're going to be at 11. So these are my 4 midpoint values. Now, you also need to know your total frequency when you do anything with standard deviation or mean, when you're doing a grouped data. So we have to add this up. So that's 8 plus 4 is 12, plus 3 more is 15. So there's 15 items total if we had the list of data in front of us. So anytime you're doing standard deviation, you have to start with the mean first. So X bar. Now I'm going to use the trick we learned in the previous section. We just do midpoint times the frequency plus midpoint times the frequency plus midpoint times the frequency plus midpoint times the frequency for each of those rows. We always divide by total frequency, the total number of items that they were tallying, okay? So that is, let's see, 6 plus 25 plus 32 plus 33. I ended up getting a 96 on the top over 15, and that equals about 6.4. It is an approximate because we're using midpoints, not exact. We don't know the exact data. We just know the midpoints. Okay, so what you're going to do, and I sometimes call these x sub k. That's how they do it in the formula, I believe. When you look at the formula for grouped data, it looks very, very similar. Like we're still adding and subtracting all of these little deviations, squaring them, and we're going to divide by n minus 1. But notice that we're also multiplying each of these by their frequency. We could have used that variation on the problem we had where there was a lot of repeats. We could have just listed 8 once, 9 once, 11 once, 12 once, 14 once, and 15 once, and we could have added a frequency column over here and said I had 2 8s, 1 9, 3 11s, 1 12, 3 14s, and 2 15s, and we could have then used that version of that formula. But I don't always jump to that if we don't have to. So the x of k's are your midpoints. So that was these 2, 5, 8, and 11. We're still going to take each of those and subtract our mean, which in this case is 6.4. I like to write it in there so we see what it is. We're going to square those, and then there's one extra step before we can sum it. When you're dealing with a frequency distribution, so you have the frequency table and the intervals, you have to take that squared part you just got and you times it by the frequency for that specific row, so FK, whatever that row is, and then you can sum this. So we are going to sum this part at the end, okay? So the sum of all of those, xk minus x bar squared f of k, okay? All right, so that's the process. So it's one extra step after we've got the midpoints and we get the mean. So we are going to be doing 2 minus, I'm going to work one row at a time. So 2 minus 6.4 is negative 4.4. Okay. Then we square that. That is 19.36. Now I sometimes write this step out so people can see where I'm getting the number from. We're timesing it by the frequency in that row. Okay, so that's times a 3. So that is 58.08. So that's the answer for the first one that we're going to end up summing. Now we're going to do 5. So 5 minus 6.4 is a negative 1.4. We're going to square that. That's 1.96. And then just to show my work, that has a frequency of 5. So I'm multiplying that by 5. It's repeated 5 times, essentially, when we talk about the midpoint as our estimator. So 1.96 times the 5 is a 9.8. Okay, then we're going to do 8. 8 minus 6.4 is a 1.6. We square that, we get 2.56. We take the 2.56, we multiply it by the frequency of that row, which is a 4, and that'll give us the value that we're going to sum. So that is 10.24. And then 11 minus 6.4 is 4.6. We're going to square that. That's 21.16. Take that value, times it by the frequency of that row, which is 3. And that gives us the value we're going to sum up. So that is a 63.48. We take and sum all those values together. Now remember, this isn't the standard deviation. This is just the numerator of the formula for the standard deviation. So 63.48 plus 10.24 plus 9.8 plus 58.08. That gives me 141.6. Now go find my standard deviation. So S equals square root. Now remember, this whole top number was all of the deviations we get by doing item minus mean. We square them, we times them by the frequency of that event, and then we sum all those together. So that's 141.6. Now n, remember, on the bottom is the 15, but we're doing 15 minus 1 for standard deviation. So that's going to be 14. So I'm going to get my calculator out. We do 141.6 divided by 15. And I'm going to take the square root of that. Now, remember I said your calculator may have you do the square root symbol first. You'll have to play around with that and make sure you're getting the right answer. It's 3.07. Let me double check myself. Did I type everything in right? No, I didn't. I did not. I was about to say that didn't match my answer. I said 14 and then I typed 15. So 141.6 divided by n minus 1, which is 14, is this long number. Take the square root of that. It is 3.18. Yeah, that didn't match my pre-written work. So I just wanted to double check that. Okay. So that is how we do that. So this one, again, this is the last problem on this video. I'm trying to keep this video a little shorter than the 10-1, 10-2, so that hopefully altogether you only have about an hour and a half of video to watch. You are going to have a worksheet to complete for in-class participation since we're not technically meeting that day, but we need to get the points. I'll be posting that right underneath both videos. So that'll be kind of your extra working time will be just completing that worksheet. It'll have a little variety of problems from all three sections that were in these videos. But I would like you to try this one on your own, just to make sure you can do a grouped standard deviation so you can reference what we did up here. I will go ahead and get you started on the midpoint because that's always a little harder when there's 2 decimal places. It just makes it look scarier. This first midpoint is 6.95 plus the 7.45. You add the 2 endpoints together, which is 14.4, and then we cut that in half. We get 7.2. So I'll write that down kind of up here, 6.95 plus 7.45, and then I divide it by 2. And then remember, you have to look at this to see how they're increasing. This time it looks like you can subtract these numbers as also to see the class width. 7.45 minus, I think they're only increasing by a half, like a half. Yeah, it's increasing by a half. So you're going to be adding a half all the way down to get, so that's going to just fluctuate between a 0.7 and a 0.2 essentially. But I'll let you finish the rest of the midpoints from there. So yeah, you have to find your midpoints first, then you can find your mean, then you can find your standard deviation. I recommend the table method. It helps you organize all your information and then make sure both answers are rounded to 2 decimal places. So try that one on your own. Make sure you check the ink to see if you got it right, because I'll fill that in before I post it. And Tuesday's class, we're going to be doing 10-4 and 10-5. So we're going to be kind of working out of order a little bit. Hopefully some of you can watch this video before we have class on Tuesday. But, you know, I figured that information needed to be covered in class more importantly than some of these formulas, because they really are just doing a process and plugging it into a formula. Let me know if you have any questions, and I hope you have a wonderful weekend.